All right, so here we're going to go through some of the basics for our CO2 car designs. So when we're looking at our CO2 cars, there's some sciences that we're going to be looking at that will help you figure out how to make your car go the fastest. The first one of those is aerodynamics. Aerodynamics is the study of how solid objects displace fluid air and other gases. That's kind of how things just move through air. Another thing we're looking at is physics. Physics is the study of matter in motion. And tribology. We're not really going to look at tribology, but this is the study of friction. You guys have a pretty generic friction about this because all of your wheels are exactly the same and the cars will go on the same track. So our friction is kind of negated in this with the materials that you have to use in this project. Okay, so there's a couple of things that we need to talk about before we get into our huge design. The first thing is understanding the problem or the purpose. Your goal, right, is to try to get the fastest car and the best appearance. You want to win both of those prizes. We have to know our limitations, okay? We have some pretty serious limitations with this project. You are limited on the tools that you can use and the time you have to spend and just the physical capabilities of the materials we're using. We're using just blocks of wood. We're not going to be able to get the most fancy designs or the best speed out of these, but we just have to know those limitations. So we have to make really intelligent decisions. We have to take what we've learned and use this to help us with our design process. And then we have to test our solution. This is going to be the very last thing we do this semester is our final test. So we want to make sure we do all of our thinking and design to help us win that race. Here are just some terms that you need to know about aerodynamics. Fluid, mass, aerodynamics, drag, lift, rear suction, downforce, and frontal area, and we're going to talk about these. The first one is air. Air is actually a fluid. Okay, so we always think about water as being fluid because it's liquid, but air is also a fluid. Air is fluid because it can be moved and displaced and directed. Air also has mass and is measured in terms of pressure. So when you'll see that on the Weather Channel a lot as they're talking about the pressure, high pressure, low pressure, that's the air. And then air also applies direct and frictional forces to objects in motion. So if there's something in motion in that air, there will be forces against it. So we're going to look at some aerodynamic principles. One of those is drag. Then we're going to look at some lift and downforce, the drag coefficient, and then frontal area. So drag is a combination of two different forces that, as you would think by the name of it, pull your car back, right? That work against you in this one. The first one is frontal pressure. Frontal pressure is where the tiny molecules of air hit the front of your car and then are forced away. So just like we talked about in class, the difference in the windshields between a bus, a school bus, and a really fast car, right? When your school bus, it's straight up and down, it's a lot harder for those air molecules to move out of the way for new air molecules. Whereas the slanted windshields of the fast cars, it's a lot easier for the air molecules to move around. The other principle that we look at is rear suction. Okay, so there can be an empty pocket of air that's created in the back of your car that pulls it kind of backwards, and you don't want that to happen. Okay, so here's a little bit more about drag. You guys have probably all stuck your hand out the window when you're in a car. You'll notice a lot more drag if you put the palm facing the front of the car, right? Then all of that wind and all of that air hits the front of your hand. Whereas if your hand is a lot flatter, you don't feel that breeze. There's not as much push on your hand. Okay, so we're looking at some rear suction here. So we'll see in this first example, there's a big pocket of air back behind this car that kind of helps pull it back. So same thing with this pickup truck. You'll see two different pockets where different air can go. Whereas this car at the bottom is much more aerodynamic. There's not as much big space for air to get stuck and to pull the car back. Okay, so lift is something else that we're going to look at. And we're also going to look at some downforce. Downforce is created by some curved surfaces that keep our car on the ground, right? Because we don't want the cars to fly off in the air, we want to keep them down on the ground. So here's the Bernoulli effect. This is kind of talking what we see on airplanes a lot. So lift, we want to go up, and here's the different pressures, right? We see how the wing is shaped and how the air flows faster. So the air that goes on the bottom of a wing, right, for an airplane, is a lot slower moving, so there's more pressure. The air that goes along the top, because it's a longer way it has to go to meet back up, it has higher pressure. So this is how we can get our things to lift off the air, which we don't really want in these cars, right? So we want to take this and kind of flip it. We want our cars to be pushed down towards the ground. So here's what we see in an airplane. We've got the thrust, which is our forward motion, which in your cars will be created by the CO2 cartridges. The drag, which we talked about, is either from that frontal pressure or the rear suction. Then we've got lift, any of the air that's moving to push the car off the ground, and just the weight of the car and how much wood you left in the car. Okay, so cars make their thrust using their engines and all that different, using gasoline. Our cars will use our CO2 cartridge. Okay, so if the drag increases, right, so if you have more frontal pressure or more rear suction, or the thrust decreases, a bad cartridge, something like that, the car will slow down. We are kind of keeping our thrust constant since we're all using the same exact cartridges, so we're really looking at drag in your design of your cars. Okay, so in an actual race car, these big fancy Indy cars, the car is designed like an upside down airplane, right? So we talked about the airplanes have lift to get it to go up. These cars make it so the airflow keeps them on the ground and pushes them down. So here the air under the car moves faster, creating downforce. So theoretically, if a race car is going fast enough, it could travel along a wall or upside down without falling because of the principles of air and how the air is working towards those cars. So here's our same cars. We're just looking at some different forces. We'll see the airflow, where the lift is created, and where some downforce is created. So another thing that can hinder or help something moving through air is friction, right? So we've got some friction. So friction is, think when you rub your hands together really slowly and you don't put much pressure, you can go really fast if you turn up the speed. But if you put a lot of force to push your hands together, you can't go nearly as fast. That's because you have more friction, which slows everything down. So you want to keep this in mind when designing your car, because you want as little friction as possible so that your car will go the fastest. So one cool thing is the dimples in golf balls actually reduce air friction. So there is a mathematical reason behind that. However, when you're thinking about this for your car, the cars are shaped very differently, and so the dimples would not actually do much help. So it's one thing to think about when you're doing your design. However, just keep in mind that you want as little friction as possible. So here are some review tips for you to help you in your design process. First thing is you want to avoid flat, upright surfaces in the front of your car to reduce that turbulence and that frontal pressure. You also want to avoid flat, upright surfaces in the back of your car to help reduce that rear suction. You want to shield as much air at the bottom of your car to maintain traction. You want to keep your car on the ground because then it will actually go forward. And the final thing is you want to keep the surface area that's exposed to oncoming air to a minimum. So you want to make the front as small as possible and get rid of as much of the frontal area as you can. Use these tips to kind of help you design your car so you hopefully will win the race that we do in May. Please let me know if you have any questions or concerns about your design, and good luck.